every human has right to know about this, has to have access to the cosmos. So we start we talk about science capital or scientific culture, because we think this is a right for everyone. So this is our main goal. But then a secondary goal is that, of course, the young people are inspired by this and they actually follow scientific careers or technical careers or careers in engineering, because we need them.
Welcome. AstroTalk UK is a not-for-profit podcast on astronomy, science and spaceflight. Launched in 2008, it's produced by me, Gurupir Singh, a writer based in the UK. I produce this podcast for my own education, but frankly, it allows me to meet fascinating people doing interesting things. It's primarily for my own education, and I share it as a free educational resource. No ads, no subscriptions, and you don't need to log in. For more, see the About page on astrotalkuk.org. Episode 100. Sandra Benitez Herrera, European Space Agency Education Outreach. Astrophysicist Sandra Benitez Herrera talks about the opportunities for teachers and students made available by the European Space Agency's CESAR program. This episode was recorded in Athens in July during COSPAR 2022. If you are a student or a teacher in Europe or beyond, Sandra explains how you can make use of CESAR's resources: optical, solar and radio telescopes, online seminars, face-to-face training and the enormous quantity of space data from the European Space Agency and other space agencies, all in one place and with no charge. She starts off with an explanation of what CESAR is.
Well, CESAR stands for Cooperation Through Education and Astronomy Research. It's a program that has been set up by ESA, the European Space Agency, together with two other institutions in Spain. One is our Aerospatial Technology Institute, and the other one is a public company from the Spanish government that is actually working more with defense matters, but has also a component in space science and outreach. And the idea is to have an educational effort that belongs to the agency but is based in Madrid, and that we reach out to local schools and educational institutions to be able to share all the materials that the agency is producing, all the scientific data in an innovative and fun way, so the students are stimulated as well to learn science.
It's an European Space Agency initiative, but it's limited geographically in Spain.
It started in Spain. It was at the beginning very local. The program has already more than 10 years. I started in 2012, or exactly 10 years now. But then with the time we have been covering other countries. We collaborate with international partners like Nucleo in Portugal, or like the Folks Telescope in the UK, or colleagues in the Astrophysical Institute of the Canary Islands. And we are setting up also international training courses for teachers, where mostly Europeans, but also from other parts in the world, teachers can actually enroll and join our programs, and they can again benefit from all the resources that we are developing.
So it's not just students, but it's teachers too. And what sort of age range of students are involved in here?
All the materials that we have developed are for really every student, from primary to high school and also pre-university level. We even have some specific projects, scientific projects with real scientific data for university students. So we cover most ranges, but as you said, teachers are also included in the program, because this is very important with us. We really want to give all the tools and resources to the teachers so they can actually go back to the schools and inspire more and more students. We reach about, we can say 500 students per year, but teachers reach much more in a year, and and especially over the years. So we use them as a multiplying factor for the message to spread. And the good thing is that this program is focused on both audiences, students and teachers.
You're based in Spain. You deal with teachers and students. It's a European project. You speak excellent English. Is the work that you do and the interactions you have with students and teachers in English, Spanish, or in all European languages?
So far we have our materials and our programs in Spanish and English, so everything is available in these two languages. But we are planning maybe in the following years, in the upcoming years, to also have other languages like French, for example, and Italian, especially because French is one of the official languages also at CESAR, in the agency. And because at the end of the day, we really want to reach the European educational community, so we are planning to expand. But the good thing is that we have everything in English, so every teacher across Europe that knows a bit of English can understand. And we also have very step-by-step guides, like they're really thorough, and they really explain all the different steps in a clear way, so every teacher can follow them and understand.
And the teacher training, it's throughout Europe. Is it in person or remote?
Well, of course, with the pandemic, we have been forced to do everything online for the past 2 years. And this year, we are organizing in October an CESAR GTTP teacher course. GTTP is the Galileo Teacher Training Program, an international institution as well for training teachers around the globe. And this is the first course in 2 years. It's going to be face-to-face, but we are also going to maintain the online option, because we think online has also increased the accessibility and the inclusion of maybe teachers that could not travel. They can also connect online. And so we are going to do half and half, hybrid mode. But it's good that we are also recuperating and coming back to the face-to-face activities. So there will be around 30 teachers coming on site in October, and hopefully hundreds of them connected online.
And would these online or in-person teachers be coming just from Europe or wider area?
The idea is to first cover Europe, but for example, for the online connections, we are going to do it open. So we have already, for example, here at COSPAR, we have already talked to teachers in India or in other countries outside Europe. They are very interested in participating, and we are probably also, of course, granting the access for them. To bring them to Madrid is a bit more difficult because the funding that we have comes from the agency, and it will mainly focus on European teachers, but the online access is for everyone.
And presumably it's online for everyone without charge?
Of course, without charge. Absolutely free, as well as our resources are absolutely free. You just can go to the CESAR website and download everything that you need there.
And you are doing some interesting things with the data and resources you have online. But before we come to that, what kind of subject matter do you teach the teachers and students? So is it, for example, observational astronomy, radio astronomy, basic geometry of science?
We actually cover most of the aspects that are researched and worked in the agency. So of course we are very focused in astrophysics and space science. So we have exploration of the solar system, we have a lot of activities about the sun, about eclipses, about the moon. We also have about more complex topics like the Big Bang, or are we alone in the universe? So all the astrophysics areas are covered. But we also talk, for example, about the missions led by ESA for Earth observation. So there are different missions like the Sentinel missions or the Copernicus missions that they are actually looking at our planet to help, for example, warning for hurricanes, for very big storms, or, for example, helping in climate change research, covering the ice melting in the poles, or even the marine currents or the salinity of the seas, that all is affected by the global warming. So there are many of these missions led by ESA that also have a lot of data. So what we are trying is also also to use this data to create educational content, so these kind of topics can also be addressed, because we think it's very important also the awareness about our planet. At the end of the day, we are a grain in the middle of this huge cosmos, and this planet is very important to be preserved. There is no planet B at the moment, so it's important for the students to, of course, know about all this knowledge in astrophysics, in space exploration, Mars, and going beyond, for example, to the outskirts of the solar system, but also that we need to take care of our planet. And then we also have activities that are more related to engineering, for example, how to build a space rocket, how do you design an instrument that is going to measure the brightness of stars, for example, like in Gaia, or that is working on astrometry. So this part that is more technical, but that many students are also interested in, we also try to cover. We actually have a resource that I'm going to tell you about. This is called SciFleet. This is a different website where you can see all the engineering models in 3D in this platform, and you can have different data about them, like what is it used for and how much it costs to build, things like that are really specific for each spaceship. And then we are going to include also some educational content there, so you can actually learn about the fleet that ESA has right now.
That's astonishing, because what you're doing is bringing real-time space-based data into the classroom, and from what you say, some of these activities will not only educate people about our world and our Earth and the urgent issues of climate change, but hopefully, and I'm guessing this is the ultimate, or at least in part the goal, is to get these young students to grow up and have careers in space.
Absolutely. On the first hand, what we want is basically to create awareness about the space and astrophysics from the basic point of view. Like, every human has right to know about this, has to have access to the cosmos. So we start, like, we talk about science capital or scientific culture, because we think this is a right for everyone. So this is our main goal. But then a secondary goal is that, of course, the young people are inspired by this, and they actually follow scientific careers or technical careers or careers in engineering, because we need them. First of all, we are going to need many of these jobs. They can really give you an amazing opportunity to contribute to your planet, to your community, to your country, and also to travel and meet other people. So on the first hand, we use astronomy as an inspiration tool, as an educational tool, but of course we want to stimulate scientific vocations and careers, and of course the young people is our primary audience.
I just wish I was 13 now compared to when I was 13. There was hardly anything like this. So you've indicated the kind of subject material that the teaching content would be. What kind of resources do you have for the teaching? Do you have telescopes and other materials that students can access?
First, we have different kind of educational guidelines, educational materials that are available at the website. As I said before, like really step-by-step experiments that you can organize in your classroom. So we have a wide variety of those, but we also have observatories, amateur observatories that we are now working on very hard to actually remoticize or even roboticize and put basically for the community, put it out there for the community. So we have right now one solar telescope that is in operation. We are now taking daily images of the sun that are then stored in our website, and then the students can actually access them to activities, for example, about the rotation of the sun, calculating the rotation period, understanding a bit more about sunspots. And now we are from August on, from September on, we are going to put in operation 2 night sky telescopes, like 50 centimeter night sky telescopes, to do like more advanced projects, maybe for high school and pre-university level. But it's not only this that we have, we also have access to observation time in a 15-meter antenna that is located at the ESA facilities in Madrid.
15 meter?
15
This is an optical telescope?
No, this is a radio telescope.
Right. Okay.
An antenna that is used actually to collect the data from the missions.
Right.
So basically the missions are downloading the data to our antenna.
So it's not a radio astronomy, it's more communication with spacecraft.
It's used for both, but it also has a component of radio astronomy, and we can use some of this time when the source is passing above the antenna. We can use this time, it's observation time, for CESAR and for educational purposes. So we also have a colleague within the project that is now working on that and developing different scientific cases and observation cases that can be started with the school year in Spain, that is usually in September and October. So we have all these equipments that the idea is to democratize science and to have it as accessible as possible. And sometimes in Spain and also in Europe, at public schools, they don't have infrastructure, they don't have telescopes, they don't have labs. So we want to use telescopes as a lab in the classroom that they can actually access online and take their own data and work with it. That's the main idea.
So that's astonishing. So you have really professional class, optical telescopes, radio telescopes, solar telescopes. And you're saying you are in the process of making them available remotely. How is that progressing? When would that be complete by?
We hope to have complete the remotization of the solar observatory by October, when the classes are starting and the students can already start doing their request for observing time. For the night sky observatory, it's going to take a little bit more. We have to do some constructions on the area where the observatory is located, which is one of the outskirts of the ESA facility, so we need to condition a little bit more the area. But I hope next year it will be ready as well. For the antennas, it's also going to be very quickly. Hopefully at the end of August, we will already have the procedure. We already have the operators that these operators are from the Aerospatial Technology Institute that I mentioned at the beginning. So this is a collaboration we have with this institution, and they are going to be the ones actually helping the students to conduct all the observations. So this is going to be very quick, hopefully in 1 month or 2 months top. So yeah, we're working very hard to accomplish that as soon as possible.
Yeah, this is really futuristic stuff compared to when I was at school. So what you're saying is that soon students will be able to log on to a web portal and request, let's say from the optical telescope, images of night sky objects like the M31, and they will just send a request and they'll get an email back with an image?
That depends. If you do it remotely, probably the operator is in the observatory, so you will connect with the operator, and you will discuss with him and interact directly with him and see what kind of targets you want to acquire. If we roboticize the project, it will be much more automatic, as you are describing. You will just enter a portal, give your coordinates, give the object that you want to observe, and you will directly receive your images to be able to work with it. Robotization is a step further from remotization. It's a bit more difficult. We are also looking for partners that could actually help us with that, like with the technical expertise. But the remotization will be for sure the best option for example, for the solar. So the students will connect directly there at the same time that the operator is, and they will be able to also control the telescope themselves.
Fascinating. So on the radio telescope aspect, let's talk about communicating with spacecraft. So students will be able to, for example, ask for an image that's just come down from Mars Express or something like that?
Not exactly. What we are going to do is to look for radio sources that are already identified in different catalogs, astronomical catalogs, and we can plan when the source is going to pass above the antenna, and we can actually observe it in radio. So basically radio astronomy at that point. For telecommunication, we have future plans to also have like more advanced projects for university level, but this is still some design in progress. So we still have not clear how we are going to do it because we want to prioritize the schools. But this radio astronomy basic observation is going to be done in a few months, as I said.
Now, Copernicus, a terrific project for Earth monitoring. Some of the images are incredibly full of data. These are multi-spectral images you take. So I'm guessing that some of the teaching aspects will be to allow students to help them understand and interpret the data that's in these images.
Yes, absolutely. And before going to the specific portal of Copernicus or Sentinel, I'm going to talk about another tool which is very useful for that, which is called ESA Sky.
ESA
Sky has all the data from the different missions, from Gaia, from the Colombo, from the past missions as well, from XMM Newton, from all the ESA missions, and some from other agencies, from NASA as well, for example, from JAXA as well. And there is very funny because you can look for an object and then you can see what kind of observations you have for that particular galaxy, for example. And you're going to have X-ray observations, are going to have optical observations, infrared observations. This is what we call skies. So you can actually overlap them and you can have the same image observed with different frequencies, with different band energies, and you can actually understand what kind of physical processes you are studying with each wavelength. So it's a very visual tool to explain exactly that to the students, that depending on which kind of eyes you are using, if it's our optical eyes or if it's an infrared instrument or a gamma ray instrument, you are going to see different parts of the same object. And so it's this multi-messenger astronomy that is now very famous in the community, and this tool is very interesting for that. The same is possible to be done in the Sentinel portal, for example. You can also overlap different kind of images that have been taken with different frequencies. It's a bit more complex because it has not been developed for educational use yet. It's only for scientific use. But the ESA Sky tool that I'm referring to, this has already some educational activities included in the platform. So it's not only that you can consult there any object that you want and see the different observations, but you also have specific lists for different activities that you can do. For example, galaxy classification. You have a list of CESAR objects that you can use for that activity, and then you can use our website and all the materials in our website to conduct the activity with this platform. So these kind of things.
It's incredibly rich and powerful resource. You mentioned, although this is an ESA project, you engage with JAXA and NASA and other space agencies. How is that relationship established? Is it something you would go to these other space agencies and ask for data, or do they say to you, can you post some of our material for your students?
Well, the cooperation and the interaction with the other agencies is a multi-level, multi-layer interaction. We have the data archive team is based in Madrid, in the ESA facilities there, and they have very, very good connections with the archives from other agencies, especially with NASA and also with JAXA or the Indian or the Chinese agencies. So basically they contribute and they share, because this is public data most of the time, so they share all the data, all the resources, and are stored in different platforms. Of course, at ESA we have our own platform, which is this ESA Sky, but basically all the data there is publicly available. And the interesting thing about ESA Sky is that you don't only have the data, but you also have the publications. For example, if I select M31, I can see all the different observations in different wavelengths, but I can also see all the publications that have been written by the astronomical community about that specific object. This is also indexed in the platform, so it's really, really powerful. And as an example of collaboration with NASA, the Hubble data is included in our platform, And also, of course, James Webb is a collaboration already between NASA, ESA, and the Canadian Space Agency. And the first images are already included as well in this platform. So the collaboration is constant and continuous.
And given that not only are the number of spacecraft and the missions increasing from each space agency, the number of space agencies is also growing. So what's the project, or what's the objective eventually for CESAR? Is it, it sounds like an ideal hub of a repository for space-related information, resources and data from all, at least all those who are willing to engage, space agencies. Is quite remarkable, because currently, if I want some NASA data or NASA images, I have to go to the NASA website, likewise with JAXA. But what you're saying is you bring it all together in one place. How big is this archive, and how do you expect it to grow?
Well, I have to say, like, what we are doing within CESAR is benefiting of this tool, this web tool that has been created by the data archive team.
Right.
So this is a very big team of more than hundreds of people that is creating this tool for the whole community, for the scientific community and for the educational community. And we at CESAR, what we have done is a collaboration with them, so we can have some educational resources specifically put it in there. Right. Of course, we work more with ESA data, but we can also work with other kind of data. So the important thing for us is always the first word of our name, which is the cooperation.
Right.
Cooperation with ESA, with the Department of ESA Education, which is also very important. We belong to the Science Directorate. We are the educational effort of the Science Directorate, but it is also a very big department of education at ESA that also fosters many collaborations. So we are collaborating with them, and of course we learn a lot from other colleagues, from other agencies, from NASA especially. They have also a very powerful program, educational program. So for us the cooperation is the key. Of course we benefit more from the ESA tools because we are part of ESA, but the cooperation with other tools from other agencies is also there, and we use them as well also for our trainings. For example, there are many resources that are also very interesting by other agencies, and not only agencies but other institutions that we use, and we hope that they will also like our tools and they will use them as well.
And finally, as you say, cooperation is the key thing. When you engage with other agencies in other countries, is it understood that material that ends up in your archives from their sources is available on the philosophy that you have, that everything is available from in your principles for free to anybody who has access?
Of course, everything that is included in this ESA tool, ESA Sky tool, for example, is clear that there has been conversations first with the other agencies to be published there, of course. Sure. Because it's true that sometimes the agencies have specific programs that, for example, the data from a mission, they are private for 1 year, for example. That means that only the scientists working in this mission can exploit them, and after 1 year they are public for everyone. So of course during this first year you cannot make them public in the archive. This is rare, it's not a common thing, at least at ESA. It's usually everything is public from moment one, but sometimes it happens because for example with James Webb, because it's a very new and important mission, it may have a period where they are not public, and of course there is always connections and conversations about what has to be published or not. So everything that is in our tool is being, of course, dealt with the agencies and is public for everyone. Yes.
That sounds terrific. So if anybody is listening and watching who's interested in either as a student to participate or as a teacher, What's the best way to contact you?
Yeah, the best way is to go to our CESAR website, which I think we will include a link in the description. And there you will have different options. One is like, for example, for teacher trainings. There is explanations there of different options that you can have during the school year, and you can just register online directly. If you want to use our resources, they are also available online. And if you want to contact us, there is also an email there that comes directly to the team, in case you are a student from France, from Slovenia, from Greece, from wherever you are, and you are interested in what we do. We can actually have a telecom with you and maybe do a Skype with your class and have the interaction and the cooperation starting. But the most important thing is go to our website and look for the contact and the form to be part of our program.
And just in case somebody's listening to the audio-only option, the website address is CESAR, as in Julius, so it's spelled CESAR.ESA.INT. I will include links on the website. Sandra Benitez Herrera, thank you very much indeed.
Thank you so much to you.